Are the voice and screen clear? All okay? Reply me. Tell me yes or no. Are the voice and screen clear? Ramesh, can you reply? Are the voice and screen clear? Screen is not visible. Okay. Okay, tell me, is that clear now? Is that okay now? All okay? Yes, fine. Now let us solve somewhat tricky questions. Now we'll see how to solve such a tricky questions, but we'll make all those questions easy. See, the method is what? The method is what? See what is given, see what is asked, how to find out the answer of what is asked. Okay, fine. A thin circular ring of mass m. What we are given? Circular ring. So I will make a note that circular ring is given to me. So question number 30 here now. But कितनी complex question you दे. This method will always help you. What we are given? We are given ring. Fine, sir. We are given ring of mass equal to capital M and radius equal to r. Mass equal to capital M, radius equal to small r. So I made a note. Is rotating about its axis with a constant angular velocity omega. Is rotating about its axis. Now they have not specified the exact axis. What does that mean? When they do not specify the exact axis, that means it is the natural axis. What is the natural axis of the ring? Passing through center and perpendicular to the plane of the ring. Passing through center and perpendicular to the plane of the ring. So in this way, you should learn to extract the data. Yes, sir. Next, with the angular velocity omega, with constant angular velocity omega, or in general omega. Fine. Next, the two objects, each of mass small m. See, the ring has mass capital M. Two objects, each of mass small m, are attached gently, means slowly, without disturbing. Okay, without producing or without generating any torque on the ring. Okay, without producing any torque. The two objects, or each of mass small m, are attached gently to the opposite ends of the diameter of the ring. Okay, what they have done? They have attached two masses, each of mass small m, on the opposite ends of the diameter of the ring. Okay, fine. So they gently place this. The wheel now will rotate with an angular velocity. आता नवीन angular velocity काय असेल circular ring ची किंवा wheel ची. So new angular velocity will be equal to question mark. Initial angular velocity was omega. Okay, initial angular velocity is given to us, and let's say final angular velocity is equal to question mark. Now you people tell me, tell me which logic we shall use. Which type of question this is? This is a type of question. Which type of question it is? This is the type of question of momentum conservation, angular momentum conservation. Whenever such kind of question is asked, what you will be doing? You will be using the concept of conservation of angular momentum. So what you will write? Initial angular momentum is equal to final angular momentum. What is initial angular momentum? I into omega. Moment of inertia initially into omega initially. And what is final angular momentum? Final moment of inertia into final angular velocity. And yes, final angular velocity we are asked. Okay, let us try to find out the answer of final angular velocity. See, right now, do we know the initial angular moment, initial moment of inertia of the system? Yes, we can know initial moment of inertia of the system. How we can know that initial moment of inertia of the system? Like this. See, initially these two point masses were not there. Initially these two point masses were not there. Initially only ring was rotating. So initially in our system only ring was present, and yes sir, initially if the only ring was present, total moment of inertia of the system is equal to total moment of inertia of the ring only. Okay, initially these 2 point masses were absent. So what is the moment of inertia of a ring about an axis passing through center and perpendicular to the plane? Passing through center and perpendicular to the plane, for ring, moment of inertia is mr square. So this initial moment of inertia of the system will be simply mass of the ring and the radius of the ring, which is small r. See, mass is capital M, radius is small r. So answer is mr square. What is initial angular velocity of the system? Sir, it was omega. It was omega. Yes, is equal to. Finally, in the system we have three objects. First is ring, second is this point mass, and third is this point mass. So three objects we have. So we have to find out moment of inertia of system finally as final moment of inertia of the ring. Sir, the ring is still rotating about the same axis. Ring is still rotating about the same axis. So ring moment of inertia will remain same. That will be equal to capital M, mass of the ring, into r square, radius of the ring square, plus moment of inertia of this point mass. How to find out moment of inertia of point mass? Sir, mr square. So mass of the point mass is small m. What is its perpendicular distance from the axis of rotation? Sir, from this axis of rotation, perpendicular distance is small r. So small r square, plus moment of inertia of this point mass. How to find out moment of inertia of this point mass? Sir, mr square. Mass is m. What is r? R is the perpendicular distance of this point mass from the axis of rotation. What is that? Again the radius of the ring. Again the radius of the ring, square, mr square. So this is the final moment of inertia into omega final. What is omega final? Omega 2. We are calling it as omega 2. Sir, we want to find out omega 2. Yes. So what to do? Omega 2 is equal to this value mr square, left hand side value mr square, whole divided by this bracket. What is that? M into r square plus m into small r square plus m into small r square. Sir, r square and r square are common and cancel. So answer will be, sir, this m as it is divided by this capital M as it is. Small m plus small m will be 2 times m. But sir, one thing is remaining here. One thing is remaining here. You made this bracket go to the left hand side. You wrote this mr square, but you have not written this omega. So I should have written that omega also here. So this is our final answer. And here, sir, capital M as it is, this plus sign as it is, and then this m plus m is 2m. So capital M divided by capital M plus 2 times small m into omega. Capital M upon capital M plus 2m. Capital M upon capital M plus 2m. This is going to be our final answer. Reply me in the chat box. Is this logic clear to all of you? Logic of conservation of angular momentum. Initial some system will be given to you, some ring or some disk will be rotating, and then point masses will be added to the system, and after adding the point masses you will be asked new angular velocity of the system. This is a particular type of question, and it is always to be found, always to be solved with this logic: initial and final angular momentum conservation. Okay, are you getting this? Reply me in the chat box, clear and written, so that I can move on to the next question. लिहा माझ्याबरोबरच कॅल्क्युलेशन करा. एकदा हे सगळं आता खालनं परत एकदा जाऊ दे. सगळं परत एकदा करायचं आहे आपल्याला. क्लियर and written? Reply me CW so that we can move on to the next question. Good. Fine, sir. You can move on to the next question now. What is the next question? Question number 35. Let's see. Now there is some graphical question. There is some graphical question. Let us try to tackle this kind of question also now. See what is given. The graph between the angular momentum Z. Now we generally call angular momentum as L, but they are writing angular momentum as Z. Okay? And angular velocity omega will be straight line passing through origin, a kind of parabola or hyperbola, inverse proportion, y proportional to x kind of, or y proportional to x square, or y proportional to x cube. Sorry, y proportional to 1 upon x, or 1 upon x square, or 1 upon x cube, inverse relation. Here y proportional to x square, or y proportional to x cube, or y proportional to x raised to 4, that kind of logic. Here y equal to mx plus c and negative slope, y equal to mx plus c and negative slope. Let's see. First decision is, or first thing is, try to find out relation between angular momentum and omega. Angular momentum is to be plotted on y-axis. Omega is to be plotted on x-axis. Fine. Now let's see what is the relation between angular momentum and angular velocity. Just give me a second. Fine. So what is that relation? Question number 35. See, angular momentum L is equal to I multiplied by omega. Angular momentum I multiplied by omega. So now you people tell me, can moment of inertia depend on L? Does moment of inertia depend on L? Does moment of inertia depend on omega? Or it depends on something else? Moment of inertia ओमेगा वरती डिपेंडेंट आहे का? असेल तर आपल्याला रिप्लेस करावा लागेल. मोमेंट ऑफ इनर्शिया एल वरती डिपेंडेंट असेल तर आपल्याला रिप्लेस करावा लागेल. Moment of inertia of a body, rotating body, does not depend on this L and omega. It actually depends on the mass distribution of the body. Okay, summation mi/ri square, where the given point particles or the point particles of the body are located. So this moment of inertia is independent quantity of this L and omega. So for this equation, this I is going to be constant. So there you can see this relation, and comparing this equation with y equal to mx, you can very easily say that it is a straight line passing through origin. It is a straight line passing through origin, and in this way you could have very easily tackled this question as option number 1. On the y-axis you will plot angular momentum. They are calling it as J, I will call it as L. And on the x-axis omega. Omega x-axis वरती आहे, y-axis वरती L आहे, आणि मोमेंट ऑफ इनर्शिया कॉन्स्टंट आहे. आणि बाळांनो हा मोमेंट ऑफ इनर्शिया हा एक पॉझिटिव्ह व्हॅल्यू असतो, म्हणजे स्लोप पॉझिटिव्ह आहे. मोमेंट ऑफ इनर्शिया पॉझिटिव्ह असतो, सो स्लोप इज पॉझिटिव्ह. सो इट विल बी दिस. It will be this. Got it? Shall we move on to the next question? Shall we move on to the next question? Question 40. Reply me in the chat box, yes or no. Everyone fast. Reply me Y or N. That won't take much time. Yes, fine, sir. Now let us move on to the next question. That is question number 40. That is question number 40. Okay. Now let us see what is given in the question number 40. Now let us see what is given in the question number 40. This is the question number 40 in front of us. Okay, fine. Seems some sort of theoretical, so we simply need to think instead of calculation. A solid homogeneous sphere is moving on a rough horizontal surface. Okay, so it is moving on rough horizontal surface. Okay, partly rolling and partly sliding. There is rolling as well as sliding, and whenever there is sliding, there is friction, and against that friction there will be some loss of kinetic energy. Okay, sir. Partly rolling and partly sliding. During this kind of motion of the sphere, total kinetic energy is conserved. Now you people tell me, if there is a presence of sliding, there is a presence of sliding friction, whenever the two objects are sliding on each other, there will be the friction which will oppose that sliding motion. See, friction always tries to oppose relative motion. Don't say that friction opposes motion. No, sometimes friction can help the motion also. Sometimes friction can help the motion also, but friction basically opposes relative motion. Friction la relative motion नको आहे. Friction can help the motion, friction can oppose the motion, but fundamentally friction opposes relative motion. And whenever there is sliding, there is relative motion between the ground and the object, and whenever there is relative motion between the ground and the object, some energy will be lost as a heat against the work done of friction. Okay, while doing the work done against the friction. So definitely total kinetic energy will not be conserved. Yes, it cannot be conserved. So option 1 is wrong. So they have written total KE is conserved. No, it cannot be conserved. Option number 2 is what? Option number 2 is angular momentum of the sphere about the point of contact of the plane will remain conserved. Now see, they are saying angular momentum conserved. For linear momentum to be conserved, net force should be 0. जेव्हा जेव्हा force 0 असेल तेव्हा linear momentum conserve होतो. आणि जेव्हा जेव्हा टॉर्क 0 असेल, whenever the torque is 0, angular momentum is conserved. So let us try to find out whether the torque is 0 or not at the about which point? At a point of contact with the plane. Let's see if this is true or false. See, if there is a sphere which is partly sliding and partly rolling on the rough floor, so definitely this sphere is sliding. Let's say this is moving like this and it is rotating also. Okay, see, it is sliding, so the sphere is moving forward with respect to the ground. So friction will say don't do relative motion. So on the sphere there will be one frictional force at this point like this. Okay, now there will be weight of the object also. We are trying to draw the free body diagram. All the forces we will be trying to draw. There will be one more force acting on this body, which will be the weight of the body mg. And they are saying that about this point of contact, angular momentum will remain constant or conserved. For angular momentum to be conserved about given point, torque about given point must be 0. And to find out the torque, you need to find out all the forces acting on the body. Now, what are the forces acting on the body? There are only two forces. First is mg and second is friction. Now, how to find out torque due to the force about this point? If you want to find out torque due to this force, what to do? Force into perpendicular distance. Force into r perpendicular. So how to find out torque? Force into perpendicular distance. Fine. Now, what is the perpendicular distance of this mg about an axis passing through this point? The axis is coming out of the plane. See, the line of action of force is passing through the point itself, passing through the axis itself. मग या axis पासून त्या mg चा perpendicular distance किती असेल? Sir, mg is passing through the axis, so its perpendicular distance will be 0. So mg मुळे येणारा टॉर्क बाळांनो force into perpendicular distance mg into 0 झाला. Plus again force into perpendicular distance कुणाचा? फ्रिक्शनचा टॉर्क. Sir, frictional force is also passing through the point of contact. Frictional force is also passing through the point of contact. So sir, we can say again force into perpendicular distance 0. आता इथं बघायचंच नाहीये कुठला टॉर्क क्लॉकवाइज आहे अँटी क्लॉकवाइज आहे. का बघायचं नाहीये? बेसिकली नेट टॉर्क कसा काढला पाहिजे? ऑल क्लॉकवाइज टॉर्क मायनस ऑल अँटी क्लॉकवाइज टॉर्क. पण इथं आता बघायची गरज नाही, कारण बाळांनो दोन्ही टॉर्क झिरोच आहेत. mg चं पण perpendicular distance from the axis coming out from this point. mg is actually passing through the axis, so there's a perpendicular distance 0. Frictional force is also passing through the axis, that's a perpendicular distance to the 0. So net torque on the object is right now 0. About this point, net torque 0. ज्या point भोवती net torque 0 आहे, त्या point भोवती angular momentum conserved. So point 2, option number 2 is correct option. Now you reply me in the chat box. Are you convinced that about this point torque is 0? So option number 2 is the correct option. कारण त्यांनी काय म्हटलंय? Angular momentum of the sphere about the point of contact with the plane is conserved. समजलंय? Just reply me yes or no. Just reply me yes or no or C. That won't take much time. You should be replying. Okay, don't sit quiet. Be active. Active ra. Good. Fine. Now let us see option number 3. Option number 3. Only rotational kinetic energy about the center of mass is conserved. See, for rotational kinetic energy to be conserved, rotational kinetic energy जर conserve व्हायची असेल, आता now we will see why option 3 is wrong. Why option 3 is wrong. Okay. So they are saying rotational kinetic energy about the center of mass is conserved. Means they are saying this omega and this moment of inertia is, let's say, I. So rotational kinetic energy formula is 1/2 I omega square. Now you people tell me, moment of inertia is not changing, that is okay. Moment of inertia is not changing, that is okay. But what about this omega? Object is rolling as well as sliding. Object is rotating as well as sliding. Because of the sliding motion, its velocity v is being decreased. This friction is like this. So translational velocity of moving forward, okay, it is moving in the forward direction. So that translational velocity is being decreased by the friction. But try to understand here, because of this frictional force, there is one anti-clockwise torque. This friction is trying to rotate this clockwise. Are you getting this? If this is an object and this is the force on the object, because of that, there will be some anti-clockwise torque. And because of anti-clockwise torque, this anti-clockwise omega will increase, because omega and torque both are in same direction. Okay, whenever the force and velocity are in same direction, velocity increases. Force and velocity in same direction means force and acceleration in same direction. Just like that, torque and angular velocity are in same direction. When the torque and angular velocity are in same direction, guys, it means that this torque will increase that angular velocity. So omega is right now increasing. So if omega is increasing, omega square will increase. If omega square increases, rotational kinetic energy is actually increasing. And if you consider the translational kinetic energy, what is the translational kinetic energy? 1/2 mass of the object into velocity of center of mass square. See, this object is also sliding forward. This object is also sliding forward with the velocity equal to v or equal to velocity of center of mass. But against this velocity, there is this frictional force. So because of this frictional force, the acceleration is opposite to the velocity, and this velocity will be decreased. This velocity will be decreased. So बाळांनो, ही velocity कमी व्हायला लागली, v कमी व्हायला लागलाय, पण ओमेगा मात्र वाढतो. Okay. So here this v is decreasing, mass is constant, but this v is decreasing, v square is decreasing, so translational velocity will be decreasing. Translational kinetic energy will be decreasing. Rotational kinetic energy will be actually increasing. So this option is wrong. Option number 4. Angular momentum about center of mass is conserved. Okay. Here they said angular momentum of sphere about the point of contact is conserved. For that we found out torque about the point of contact and we verified the answer. Now here they are saying angular momentum about the center of mass is conserved. Let's see, angular momentum about the center of mass is conserved or not. For angular momentum to be conserved about the center of mass, torque about center of mass must be 0. Yes. Now our axis is this. Now how to find out torque? To find out torque, what you have to do is find out the forces acting on the object. The first force is mg. First force is mg, which is passing through the center. So total torque about center of mass will be equal to all clockwise minus all anti-clockwise. Okay. This mg, torque because of this mg will be equal to what? Sir, mg is actually passing through the axis. Mg is also passing through this point, also passing through this point. So perpendicular distance of this force, force into perpendicular distance is the torque. So because of this force, what is the perpendicular distance from the axis? 0, because mg is passing through the center of mass. So force into perpendicular distance, mg into 0. Fine. Now sir, torque because of this frictional force. Torque because of this frictional force. What is the torque? Force into perpendicular distance. What is the force? Sir, force is F. What is the perpendicular distance? Radius of the sphere. So whether it is clockwise or anti-clockwise torque, sir, it is anti-clockwise torque. Net clockwise torque equal to all clockwise minus all anti-clockwise. Sir, this torque due to the frictional force is anti-clockwise torque. Try to observe. Because of this force, object will rotate. Sorry, not anti-clockwise. My mistake. Because of this force, object will rotate clockwise and not anti-clockwise. Because of this force, object will rotate clockwise. So torque of this frictional force is a clockwise torque. So all clockwise minus all anti-clockwise. mg is other kai alas nahi, because perpendicular distance of mg was 0. So mg into 0, force into perpendicular distance. Now this F has perpendicular distance as r and it is a clockwise torque. So all clockwise karayche. Frictional force into r, all clockwise minus all anti-clockwise. आता दुसरे कुठले forces नाहीच आहेत. Only two forces are acting on the body. First is mg and second is friction. So this is the net torque. See, the torque is F into r. mg into 0 is 0, but torque about center of mass is F into r. So there is net torque. That torque is not 0. If torque is 0, only then angular momentum is conserved. If torque is 0, only then angular momentum is conserved. But here torque is not 0. F into r, some non-zero value is there. So angular momentum will not be conserved. And here they are saying that it will be conserved. So option 4 is wrong. So all the justifications clear to all of you? Reply me in the chat box. Everyone, first. Reply me in the chat box. Everyone, is this justification clear to all of you? We are at the end of the lecture now. We have solved all the questions number 5, 10, 15 and so on from the chapter from the exercise number 1. Clear hai ka? Yes. Now in the next lecture we will be solving the higher level questions, that is exercise 2 questions. Okay, same exercise number 2 question, exercise 2 questions in the next lecture. Okay, fine. So in this lecture we will stop at this point. Chalo, bye bye everyone. Let me end this lecture at this point. Okay, have a good day. Let me end this lecture at this point.